The Automatic Flight Control System, the AFIS, is an electromechanical servo system installed in the helicopter to improve its aerodynamic stability. The AFIS is intended to be engaged on the ground before takeoff and left engaged until landing. The AFIS system consists of the following components: the AFIS amplifier, the channel monitor panel, the control panel, stick position sensors, pedal switches, release switches, dual channel lag amplifier, remote stick panel, compass gyro, vertical gyros, oscillatory shutoff unit, the OSU, barometric altitude controller, flight director. Component description: the AFIS amplifier. Located in the upper nose compartment on the cockpit floor, the AFIS amplifier compares, modifies, and amplifies signals from the gyros, position sensors, and switches, directing the correction signals to the servo and trim valves on the AFIS servo unit. The amplifier consists of 9 fuses, a yaw rate gyro, 5 modules, cards, yaw sync, pitch, roll, yaw, and collective. The 4 gain capsules, pitch, roll, yaw, and collective. The pitch, roll, yaw, and collective modules are interchangeable. Channel monitor panel. Located in the overhead console, contains a 4-channel disengage switches. The channel disengage switches enable the pilot to disengage as desired. For example, if the yaw channel of the AFIS should malfunction, the pilot could disengage the yaw channel and fly with stability in all other channels. Internally, the channel monitor panel houses a 3-minute plus/minus 30-second thermal time delay relay. Beginning at the time AC power is applied to the helicopter, the relay prevents engagement of the AFIS until the pilot's gyro has had time to come up to speed. Control panel. The AFIS control panel is located on the center console. The panel contains controls normally used by the pilot to operate the AFIS. The switches and controls located on this panel are AFIS button, a normal open momentary control switch which has a green light in its center that illuminates when the AFIS is engaged. Bar out, a normally open momentary control switch which has a green light in the center that illuminates when the bar out is engaged. The red button below and right shuts off that bar out hold. Roll trim control, used to adjust the AFIS system, compensating for lateral stability. AFIS servo switch, controls hydraulic pressure to the AFIS servo. Yaw trim control, used in conjunction with the yaw channel and enables the pilot to make minor heading changes when the AFIS is engaged. The control is calibrated so that each division is equal to 2 degrees of helicopter heading. CG trim control, used to adjust the AFIS system, compensating for various CG loading of the helicopter. Stick trim switch, turns the stick trim switch on or off. The stick position sensors. The stick position sensors located in the control broom closet are connected to the pitch, roll, and collective flight control linkages, just below the AFIS servo unit. They oppose the vertical gyro signals, providing reference signals for different flight attitudes in pitch, roll, and collective. The pitch and roll stick position sensors provide a reference signal to the dual channel lag amplifier. Pedal switches. The 4 micro switches located on the left and right pilots and co-pilots' pedals place the yaw channel in a synchronizing mode when manual turns are made with rotary rudder control pedals. Cyclic stick and collective release switches. The release switches located on the pilots and co-pilots' cyclic sticks are labeled AFIS release, and release switches located on the collectives are labeled AFIS servo off. When depressed to the off position, the AFIS servo off switch disables the AFIS servo in all modes of remote stick. The pedal dampener is also disabled and only the yaw synchronizer is operative. The AFIS release switch on the pilots, co-pilots, and aft cyclic disables all channels of the AFIS system in all modes of remote stick, with AFIS and aft pilot's normal stick switch engaged. Depressing the aft pilot's norm off switch will disable the normal remote mode and causes the remote stick to switch from normal mode to auxiliary mode. With the AFIS and auxiliary stick engaged, depressing the aft pilot's AFIS release switch will disable the AFCS dual-channel lag amplifier. The lagged circuit lags any change of the stick sensor's signal so that it matches the lag in the pitch and roll gyro signal. The lag of the pitch and roll gyro signal is due to lag in response of the helicopter mass to a cyclic stick movement. The stick sensor output must be lagged in order to make it coincide with gyro displacement signal. The amplifier is located in the nose under the avionics shelf. Remote stick panel contains the remote stick AFCS engine, aux eng, norm, and aux off switches, and the pitch and roll indicators. The remote stick provides the aft-facing pilot with pitch and roll control. The remote stick grip is mounted in a gimbaled arrangement that enables the grip to be tilted fore, aft, left, and right for cyclic control. The movement of the stick develops electrical signal voltages that move the AFCS servo valves in the same manner as the AFCS. The remote stick grip contains a hook release, stick release, AFCS release, and ICS switches. The stick release switch is used to disconnect electrical power from the remote switch. Compass gyro G14, located on the cockpit floor behind the center console. The compass gyro provides inputs into the control panel, which are summed with a yacht trim control knob to provide heading information to the AFCS amplifier. Vertical gyros are two vertical gyros. One is mounted on the tilt table located at the right side of the winch well, and one is located on the cockpit floor left of the AFCS amp box. The vertical gyros sense helicopter pitch and roll attitudes and transmit those displacement signals to the vertical gyro indicators and to the AFCS amplifier pitch and roll channels. Oscillatory Shutoff Unit, OSU. The OSU mounted in the nose of the aircraft on the bottom shelf in front. It senses excessive inputs in pitch, roll, yaw, and alt channels. Shut off the AFCS. When the ASU senses an amplifier oscillation in excess of 50% of the output level in the pitch, roll, and barometric altitude channels, or 75% from the yaw channel amplifiers, the relay in the OSU de-energizes and the AFCS is automatically disengaged. The unit contains 4 fuses, 4 spares, and 4 test buttons. The test buttons allow you to check each channel for proper shutoff. Barometric altitude controller, located on the cockpit floor in front of the right seat pedals. It provides inputs to the AFCS amp to control the constant altitude function of the AFCS. Flight director is mounted in the right side of the instrument panel. The flight director indicates the strength and direction of a pitch, roll, yaw, or collective signal to the servo valves from the AFCS amplifier. The vertical gyro indicator, VGI, receives input from the winch well gyro, giving the pilot a reference to aircraft attitude. AFCS block diagram. Pitch channel operation. The pitch channel of the AFCS improves dynamic stability around the lateral axis of the helicopter. Whenever AFCS is engaged and some outside force causes the helicopter to pitch up or down, the vertical gyro senses this motion and inputs a signal to the amplifier. The amplifier analyzes the signal to determine which direction, how far, and how fast the nose is moving from the selected attitude. From this, a corrected signal is developed to bring the nose back up as soon as possible with minimum overshoots. The correction signal is sent to the AFCS servo valve and immediately causes the flight controls to reposition, moving the swash plate and rotor blades. When the helicopter returns to its selected altitude, the signal from the gyro also returns to its original output. The amplifier output, because it again sees no difference between desired and actual attitude, will return to 0. This returns the servo valve to neutral, which returns the flight controls, swash plate, and rotor blades to the position originally required for selected attitude. Roll channel operation. The roll channel of the AFIS improves dynamic stability around the longitudinal axis of the helicopter. Whenever the AFIS is engaged and some outside force causes the helicopter to move around the longitudinal axis, the vertical gyro senses this motion and inputs a signal to the amplifier. The amplifier analyzes the signal to determine which direction and how far and how fast the helicopter is moving from the selected attitude. From this, a corrected signal is developed to bring the helicopter back as soon as possible with minimum overshoots. The correction signal is sent to the AFIS servo valve immediately, causes the flight controls to reposition, moving the splash plate, the rotor blades. When the helicopter returns to its selected attitude, the signal from the gyro also returns to its original output. The amplifier output, because it again sees no difference between desired and actual attitude, will return to zero. This returns the servo valve to neutral, which returns the flight control, splash plate, and rotor blades to the position originally required for the selected attitude. Yaw channel operation. The yaw channel of the AFIS improves dynamic stability around the vertical axis of the helicopter. Whenever the AFIS is engaged and some outside force causes the helicopter to move around the vertical axis, a proportional signal from the compass C14 gyro senses this motion and inputs a signal to the yaw synchro in the amplifier. The amplifier analyzes the signal to the yaw to determine which direction, how far, and how fast the helicopter is moving from the selected attitude. From this, a corrected signal is developed to bring the helicopter back as soon as possible with minimum overshoots. The correction signal sent to the AFIS servo valve immediately causes the flight controls to reposition, moving the tail rotor and rotor blades. When the helicopter returns to the selected attitude, the signal from the gyro also returns to its original output. The amplifier again sees no difference between desired heading and actual heading, and its output will return to zero. This returns the servo valve to neutral, which returns the flight control servo and rotor blades to the position originally required for the selected attitude.